In our last video, we explained how urban flooding happens and why communities like Milton are at risk. But flooding isn't just about the weather, it's also about how we build our cities. In this video, we'll explore how different surfaces affect stormwater, the alternatives to traditional pavement, and the strategies communities use to reduce flood risk. Imagine two identical rainstorms. In a natural environment, rain falls onto grass, forest, and healthy soil. Most of that water infiltrates or soaks into the ground, where it becomes groundwater or is absorbed by plants. Some of it evaporates back into the atmosphere, while only a small amount flows into nearby streams. Now imagine that same storm in a city. Instead of grass, the rain lands on roads, parking lots, sidewalks, and rooftops. These hard, impermeable surfaces prevent water from soaking into the soil. Instead, the water rushes across the surface, overwhelming storm drains and increasing the risk of flooding. The more pavement a city has, the more runoff it creates. Fortunately, engineers have developed several alternatives that allow rainwater to pass through the surface instead of flowing away. One option is permeable interlocking concrete pavers. These concrete blocks have small gaps filled with stone or gravel, allowing water to drain between the pavers while still supporting vehicles and pedestrians. Another solution is porous asphalt. Unlike traditional asphalt, it contains larger stones and fewer fine materials, creating tiny spaces that let water pass through. Permeable concrete works in a similar way. Its open structure allows rainfall to infiltrate while still providing the strength needed for roads, sidewalks, and parking lots. For lower traffic areas, gravel or crushed stone offers excellent permeability and is commonly used for pathways, driveways, and stormwater management areas. Playgrounds and recreational spaces can use permeable rubber surfacing. It not only allows water to drain, but also provides cushioning for improved safety. Another effective solution is bioswales. These are gently sloped vegetated channels that capture stormwater, filter pollutants, and allow water to soak into the ground or enter underground drainage systems more slowly. Together, these solutions reduce runoff before it becomes a flooding problem. Now the question is, if permeable pavement has so many benefits, why is asphalt still the most common paving material? The biggest reason is cost. Traditional asphalt has a lower upfront construction cost, and with regular maintenance, it remains one of the most economical pavement options over its lifetime. It's also quick to install. Unlike concrete, asphalt doesn't require a long curing period, allowing roads and parking lots to reopen much sooner. Another advantage is flexibility. Asphalt can be engineered to withstand heavy traffic, hot summers, and Ontario's repeated freeze-thaw cycles during the winter. Finally, asphalt provides a smoother driving surface, reducing vehicle wear and tear while improving fuel efficiency. Although asphalt remains practical in many solutions, cities are increasingly combining it with more permeable solutions to improve stormwater management. Ontario already has many companies producing flood-friendly paving materials. Companies like Oaks Landscape Products, Unilock, and Permacon manufacture permeable concrete pavers designed for Canadian climates. Romax provides permeable hardscape systems along with design support and installer training. Stormflow Surfacing produces environmentally friendly permeable pavement using recycled tires. Meanwhile, EcoRaster and Han Plastics manufacture recycled plastic grid systems that can be filled with gravel or grass to create durable, permeable surfaces. One of the most effective approaches to managing stormwater is called low-impact development. Low-impact development focuses on keeping rainwater where it falls by allowing it to infiltrate into the soil rather than trying to move it away as quickly as possible. This follows the natural water cycle. Normally, precipitation infiltrates into the ground or is intercepted by vegetation and eventually returns to the atmosphere through evaporation and plant transpiration, a process called evapotranspiration. Runoff should only occur when the soil can no longer absorb water or when rainfall is falling faster than the ground can absorb it. Low-impact development helps restore this natural balance. Some common techniques include the following: bioretention systems and rain gardens, which use specifically designed soil and plants to absorb water while filtering contaminants; permeable pavement, which reduces runoff, removes pollutants from stormwater, lowers flood risk, reduces stream erosion, and even helps reduce the urban heat island effect; stormwater tree trenches, where trees are planted in engineered underground systems that capture rainwater while cooling cities, improving air quality, storing carbon, and providing wildlife habitats; stormwater landscaping, which is one of the most affordable methods. It produces cleaner runoff, requires relatively simple maintenance, and creates attractive green spaces; green roofs, which are specifically engineered rooftops covered with vegetation. They absorb rainfall, improve air quality, reduce building energy costs, increase biodiversity, and reduce the amount of stormwater entering drainage systems; rainwater harvesting, where rainwater from rooftops is collected in storage systems for future use, reducing the demand on municipal water supplies; And lastly, soak away infiltration trenches and chambers. They're underground stone-filled reservoirs that temporarily store runoff and slowly release it into the surrounding soil. Together, these systems mimic nature and significantly reduce flooding. Organizations like Conservation Halton play a critical role in protecting communities from flooding. They operate flood control infrastructure, including dams at Hilton Falls, Kelso, Mountsburg, and Scotch Block, as well as flood control channels in Milton and other communities. These structures help hold back and redirect water during major storms. Conservation Halton also operates a flood warning program that continuously monitors weather forecasts, rainfall, and water levels. Beyond emergency warnings, Conservation Halton also guides land use planning to prevent development in floodplains, wetlands, ravines, and other natural hazard areas, helping protect both people and the environment. Creating flood-resilient communities requires action at multiple levels. First, homeowners and businesses can reduce the flood risk through incorporating greenery into the land use, as well as collecting and reusing rainwater. Second, communities can work together through flood preparedness, emergency planning, and resilient infrastructure. Protecting entire watersheds, shorelines, wetlands, and natural floodplains ensures that nature continues doing what it does best, absorbing and storing water before it becomes a disaster. Urban flooding isn't inevitable. By replacing traditional infrastructure with smarter, more sustainable designs, communities can better manage stormwater while protecting people, property, and the environment. From permeable pavement and green roofs to rain gardens and watershed protection, every solution helps cities become more flood resilient. As our communities continue to grow, building with nature instead of against it will be one of the most effective ways to reduce flooding for future generations.